Hello everyone, my name is Contajo and today I will be explaining my solution for the MHF 4U Unit 4 mid-unit assignment. The first question gives us the average monthly high temperature for the yellow knife. We are asked to create a trigonometric equation where y represents the temperature and x represents the mass number. From the table, the highest temperature is 21 degrees Celsius. The lowest temperature is minus 24 degrees Celsius. Why? To find the to find the amplitude, I take the difference between the maximum and minimum and divide it by two. To to 21 minus negative 24 give 45. The 45 divided by 2 is equal to 22.5. So the amplitude is 22.5. Next, I calculate the average of the maximum and minimum. 21 plus negative 24 equal negative 3. So divided that by 2 and we get minus 1.5. So the midline is y equal to negative 1.5. Next, the period. Next, for the period, here the temperature cycle repeat every 12 months. So the period is 12. Using the formula K equal 2 pi divided by period K equal 2 pi over 12, which simplify into pi over 6. Since the highest temperature happened in July, which is the month 7, I shift the cosine function 7 unit to the right. So the final equation is that y equal 22.5 cosine of pi over 6 pi 8 minus 7 minus 1.5. Moving on to question 2. Two Question 2, we are told that the diameter is 10 meter. It takes 24 seconds to make one rotation. The lowest point is 1 meter above the ground. Then write the stat as the lowest point. lowest point. We will find the amplitude first. For finding the amplitude, means the diameter is 10 meters, so the radius is 5 meters. The amplitude is equal to radius, so the amplitude is 5 meters. For in this file, I use another method, but we can still use two method. Yeah. For the midline, since the lowest point is 1 meter above the ground, the radius is 5 meters. The center of the wheel must be 5 meter above the ground. So the midline is y equal to 6. And for the period, we complete one rotation in 24 seconds. So the period is 24. K equal to pi divided by 24, which simplifies to pi over 12. That's because of the right step at the lower point, I use the negative cosine function. So the equation is h of t equal to minus negative 5 cosine of pi over 12 t plus 6. To check if this is correct, I substitute t equal to 12. 12 and 12 is the half of the 24, so the writer should be at the highest one. When I substitute 12 into the equation, I get 11 meter. With this match the actual maximum height because the lowest height is 1 meter, the diameter is 10 meters, so the highest height is 11 meters. Okay, that confirms the equation is correct. Correct. Two other correct val two other group check values would be t equal to 0, which I use in this, and t equal to 6, which also I use in this file. Yeah. Moving on to another question 3. We are given the low tide is 4.5 meter as 2 2 208 a.m. and height is 70.3 meter at 8:21 a.m. First, we'll find the amplitude. As usual, I subtract the low from the height. 17.3 minus 4.5 equals 12.8. Divided by 2 and we get 6.4. So the amplitude is 6.44 meters. Next, we'll find the average. Find the average. 17.3 plus 4.5 equal to 21.8 and divided by 2 and I get 10.9. So the midline is 10.9. Period, the period, the time from the low tide to mid tide is 6 hours and 13 minutes. So that represents a half of the cycle. So the full period is approximately 12.44 hours. Using the formula for K equal to 2 pi divided by 12.44, which is approximately 0.505. 505. Since the cosine since the since the cosine start at measurement and the high tide happens at 8 8:21 a.m. I convert that into 8 decimal form. 8 decimal form. On 8 plus 21 divided by 16 equal to 8.35 hours. So the final equation is h of t equal 6.4 cosine of 6.4 cosine of 0.505 time minus 8t minus 8.35 plus 10.9. When when t is when t is at 11:30 a.m. in decimal form is 11.5. When I substitute that into the equation, I get the approximate 10.8 meters. The boat at least need 12 meters of depth using a graphing approach. I determine that the tide is above 12 meters from the approximately 5:30 a.m. to about 11:10 a.m. So the boat can dock during the time window and must leave once the tide below 12 meters. That's all for this assignment. Don't forget to subscribe and I will see you in another assignment.